Lesson 13.3, histograms. We're going to analyze some data in both a chart or a table and then turn it into a graph. So we've got some data here, and I've written it smaller so it is easy to see. It's the population. I gotta watch out the way I use the stylus here. Population of counties in Maine and the number of counties that have that population. So if you're not used to looking at data, this is in thousands. It's saying that there are 7 counties in Maine that have between 0 and 50,000 people. It's relatively small if you don't know that. There are 4 counties in Maine that have between 50 and 100,000 people. That's not too unreasonable. Depends on how big the county is. 3 between 100 and 150, and so on. 0 between 200 and 250. And then 1 all the way up here at the end with 250 to 300,000 people. So that's probably got the biggest city in the state and a big chunk of people. So that's one way to look at data. We're going to use something called the histogram, which a lot of people are used to. So they break the data into 2 things, measurement classes and frequency. The column on the left are the measurement classes, between 0 and 50, 50 and 100. In this case, they're given to us. You can pick whatever you want. The ones on the right are the frequencies. How many times does that occur in each measurement class? So here's some data, the same data that's been put into histogram form. And I'll show you how to do that momentarily. And if you look, it says 7 counties have between 0 and 50,000 people. 4 have between 50 and 100. It's the same thing. So we look at this, and it's a little bit easier, but not that much, to say what is the median of this data. And for those who don't remember, a median is the middle data point. For example, if you were to line up some test scores and you had a 70, a 72, a 73, an 80, and an 83, you'd say, boy, this class obviously didn't study for their rational equation, for their test. But then you would also say the median value would be the middle one, the value that's in the middle, if I line them up. Median value, if there's an even number, so there's no middle value, you would just take the middle 2 numbers and average them. So back to this, we have 7 data points in the first column. We have 4 in the next one, 3 in the next one, 1 in the next one, 1 in the last one. Add them up. We get 16 data points. And so the median data is going to be between 8 and 9. Where does that occur? Well, there's 7 in the first one. There's 4 in the second. So it'll occur in the 50 to 100 range. So that's the 50 to 100,000 range of data. That's where the median is. That's a little tricky. I think you can handle it. Just keep your eyes and ears open. You'll be fine. Looking at the data now that we've put it in a chart, we can describe it. How would we describe this data? Well, you could talk about the data a lot. So you would say only one big county, lots of small counties, smaller counties. Maine is not exactly overpopulated. Very beautiful if you've ever been there, but it's a very rural, small town feel. But what we do when we see this big data point off to the left, we say it is skewed to the left. And all that means is that the data kind of bunches up on the left side. We could also say it's skewed to the right. We could say it has a central tendency if it was one of these sort of things. So you've got all sorts of options. Don't worry about it too much. Just do understand what skewed means, pushed off more to one side than the other. So Hard part, create a histogram of your own. Use the following data. All of these are just random points. And in this case, I'll say it's the scores out of 50 on a math quiz. So first thing you do, what's the range of the data? And you look carefully and say it goes from 22 to 47. So now you have to create your measurement classes, and you can pick whatever you want. You want one that doesn't have like 50 in one category and 1 in another category. So we're going to go by fives. We're going to go 20 to 25. And we'll say it can be 20. We'll call S the score, but we don't want it any bigger than 25. This one's the 25s up to but not including 30. And this one's the 30 up to but not including 35. Fairly laborious process. This is what God invented computers for. And then you'd actually sit down and pull each data point off. Say, oh, there's one here, and there's one here, and there's one here, and then there's another one here. So I've done that already. There's 2 in this category, 3 in that category, 6 in that category, 7 in that category, 8 in the second to last category, and 1 in the last category. So take that data and draw your histogram. This is 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50. I got lucky. And it went up as high as 8, so go there, close the top, and give it a label. Always label your graphs. Mathematics, test scores. And I forgot to label this side, so this is just the frequency. One, two, three. Don't need to do more than that. Down here is the score. I'm going to use different colors. You do not need to, just because it's easier to see. You do not need to shade it. Again, I'm just trying to make it a little easier to see.
Ryan O'Toole, please come to the attendance office. Ryan O'Toole, please come to attendance.
Next one goes up to 6. Next one goes up to 7. Next one goes up to 8. Last one is just 1. There's your histogram. Made it a lot more colorful and detail-oriented than you needed to, but you're just trying to represent data. So if I was a teacher, I would say, looks like they did fairly well. Overall, I would say no super scores. Not no, but few super scores. So it was a challenging test. Not too many people got above a 45, just one. Few people in big trouble. And so on and so on. Now I look at the data, I can make some sense of it. It would appear that there are 2, 5, 27 scores. So the mean will fall on the 14th score, which is right about in the 7 category. So the mean is in here. Pardon me, median would be in that one. That's about it. You're going to play with these. They're not challenging. They're just to open your mind a little bit. Other ways that we can represent data. That's it. Good luck.